Hello there. Today we'll be doing the bottom-up approach about the decode ways. This is going to be our 98th problem today. Well, not today, but overall. And we have already done the top-down approach, as you can see here. Let me just review that one more time. What we're gonna do is to ask for how many ways to get the whole entire string and items. And we're going to ask, so let's suppose we take one item, or we take two items. If it's possible to take two items? If it's possible to take one item, then we're going to just set it to that next item. If it's possible to take two items, then we're going to add those options to our current number of ways to do that, as you can see here. And then we're going to return that result of our particular item. One thing to note is that what we're going to do here is that we're going to store our I, so that when we ask for the the DFS of that point item, we already have it. As you can see here, I plus 2, I plus 1. As you can see, there are going to be repeated items that we're going to see here. As you can see, if we let's say we add another item here, we'll see that item later. So with that, we know that we can do a bottom-up approach by reversing the problem and looking at the last item and building up to our final item. So how to do that is pretty simple. What we're gonna do is same thing. We're gonna keep our dp equals the length of s. Set it to 1. So there's our base case. And so we're going to set for I in range of length. We're going to set it the last item. -1, -1, -1. And so basically, you see this line of code here where we return 0. What we're going to do instead is if s of I equals 0, we're going to set the dp of I equals 0. That's essentially the same thing as what we're doing here, because if it's 0, that means there are no possibilities from that location. So else, we're going to do a dp of I equals I dp I plus 1, which is the choosing a single item rather than choosing a double item and getting those possibilities. And then if I plus 1 is less than the length of s, and basically same code again, is of 1, or s of I equals 2, and s of I plus 1 in these items 0, 1, 2, 3, 4, 5, 6. Let's get dp of I plus equals dp of I plus 2. Let's get those next two items. And so with that, we can return dp of 0, and that's all of the whole problem. One thing to note is that we're going to review this in a little bit after we submit the code and make some correlations about like how we converted that code. Okay, perfect. What happened here was that we chose a single item, and we're working backwards again. We're just building up completely backwards without going forward. We're just starting at the end and building up our answer. So starting at the end, we started with a 1, and we found, let's check the 2 out, and we got the 2. Is 2 with the 1 going to be more than that? Well, yes, it's going to be more than that, because you can choose either this possibility here or this possibility here. So we added those possibilities together, and then we chose the 1 or the other one, and we added those possibilities together too. So yep, that is the bottom-up approach. Is exactly the same as the top-down approach, without going from the top down. So how many ways is there to choose 1? How how many ways is there to choose a 2 and a 2, 1, and how many ways is there to choose 1 and 1, 2. Did that make sense? That probably didn't make sense. Let me try it one more time. Top down, we chose a 1, 2, 1 and found out that, okay, so we're going to take the possibilities of choosing, we're going to add the possibilities of adding 1 number and 2 number. Adding the possibilities of 1 number is basically not adding anything. So basically we pull it from the next one. And let's say, and then this one is, if we had 2, then we had 12. So let me give an example. Let's say 3, 3, 3. That's a very good example. So 3, 3, 3, there's only one way to get 3, 3, 3, 3. And so basically we're going to pull, so there's only 3. Then we're going to pull the 3, and then we're going to pull the 3. So in DFS, so there is no way, there's only one way. With that, we found out that that's how we do this particular item. And if there are 2 ways, like 3, 3, 3, 1 at the last item, well, there's no way to do that either. So 1, 1, 2. So let's say 0 to make this simple. So we get our 10. So so there is one way to choose 1 and another way to choose a 10. Of course, 0 only returns 0. So then there's only one way to choose the 1 plus the 2, which is a 10. Yeah. And that's it. So I think that made a little bit more sense by showing off that 3, 3, 3, 1, 0, that particular example, so that we can understand what's going on here and what choices are we're making and what we're looking at when we pull that last item, or a second last item, or third last item until the first item. So that's how we solve this particular problem. I'm sure that there are many ways to solve this problem, and there are different ways to think about this particular problem. But we're gonna think about it this way until it's very concrete in my mind. And then once it stabilizes, and it's like playing music, it'll stabilize if you play it enough times in your brain. And once that happens, then you can move on to a different pattern that you can store. But currently, this is the pattern that we're going to go off of. We're going to run the top-down approach. Then we're going to do a bottom-up approach to like further enhance the pattern of a dynamic programming problem where there's that ask for these types of answers. I hope that was not too long-winded. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. And I thank you very much for watching, and I'll see you in the next one.